we already discussed briefly the path-defining word ND, which allowed us to define a path from one node where we're executing the snorkel and ganglia code to, for example, an edge node which has a master in, slave out connection or a chip select connection. In order to use that path, we have two words that are defined for us in polyforth, rfetch and rstore. So, for example, rfetch takes an address in a already set up path to a remote node and returns the value at that address. Similarly, rstore takes a double word, we'll discuss why in a moment, and an address, and stores the data at the address in the remote node. In this example, we're going to store and retrieve from a register in the remote node. The register we're going to use is the IO register, and in every node the IO register is at hex 1DA. In this particular case, we've assumed we've set up a path called chip select, or defined a path called chip select, which connects to a particular pin on the I/O. Here we invoke that path, and here's our double number. Here's the address in the remote node, and we store. Now, why is it a double number? This is one of the interesting features when you're running a virtual machine on top of a real machine. In this particular case, the virtual machine is a 16-bit virtual machine. It has 16-bit word width, whereas the native word width is 18 bits. The IO register that we wish to access on the remote node is an 18-bit register. So in order for us running polyforth in 16 bits to access an 18-bit register, we treat it as a double precision number. In this case, in polyforth, the most significant part of the 18 bits, or the double number, is on the top of stack, and the least significant is beneath it. In the IO register, the two most significant bits control if it's an output or an input for a digital IO line, and if it's an output, the next significant bit controls whether it's high or low. In this case, we're setting the IO register to be an output with 0 in it, and that's what we're sending out, a 0 out the chip select line. If we wanted to send a 1 out the chip select line, we change this from a 2 to a 3. So we'd set the IO bit to say it's an output and the value 1, a high. So of course when we're using the chip select on this particular device, we want the chip select to go low, so we might have a word called chip select low, which might look like 02 IO rstore, and another word we might define, which might be chip select high, which would be 03 IO rstore. And I've left off the path setup, which should be chip select. And of course, if we're defining it, we say a colon at the start. And a semicolon at the end.